Yeah. Recap, regularization, third unit. As of now, we have learned so many concepts which are essential for regularization. Why we are using regularization, optimization. Simply, we can say optimization, or we can control the model based on capacity value. We can control. So those are very essential for deep learning that we discussed in the last class. And what are the strategies we are following to regularize these? This is one of the strategy, parameter norm penalization by adding penalties. So we are doing regularization task. So another strategy is norm penalties as constrained optimization. So here we are using some constant constraint. So how we are applying all these things means on normalization omega of theta. Okay, so sigma into omega of theta. So with the output value, so we are applying all these things we learned in the last class, and also regularization under constrained problems. So constrained optimization and under constrained problems, those things we learned in the last class. Along with this, we have learned dataset augmentation. So dataset augmentation is one of the strategy like norm penalization, parameter norm penalties. Similar to that, this is one of the simple augmentation. So this concept we covered in the last class, and noise robustness as well as semi-supervised learning model. So we defined one supervised learning model and unsupervised learning model. So based on this, we defined one semi-supervised learning model. So this is also we have covered in our last class. Out of which all you just remember the thing is we are doing optimization, regularization. So why we are doing this regularization means to control the model for generating the minimum error, generalization error. So now today's class, we would like to cover multitask learning. How this multitask learning is useful in deep learning algorithms. From here, everything is considered in terms of deep learning only, third unit. So early stopping. What is the importance of using early stopping? Okay, multitasking. And also we can learn sparse representation, how we are representing in terms of sparse our data elements, and how we are updating the weight value. So we are using bagging and ensemble models, optimization models. So these are all also called regularization models. So those we are using. So we are going to learn all these concepts today. And a dropout. The important one is a dropout. So this is very, very important one in deep learning networks, because while designing a network, when we are using deep networks, network structure is very high. So it is very important to use dropouts sometimes. Those topics we'll see in today's class. And adversarial training. So this kind of training we should see how it will be implemented, and some of the optimization deep learning algorithms. Some of the optimization deep learning algorithms like basic algorithms, so parameter initialization strategies, basic algorithms, or adaptive learning algorithm, these algorithms. So we will see how we are doing optimization. This optimization is very, very important thing in the development of deep learning model like ChatGPT. So these concepts we'll cover today. So now we'll start directly. Already it is 9:40. So now we are continuing our session. So this is a multitasking. What is the multitasking? So why we are using this multitasking in our regularization? Multitasking is one of the essential part. So see here, multitasking is a way it improves a generalization by pooling. You just remember this pooling examples with arising out several tasks. That means we are doing developing a model in different by applying different tasks. Out of these several tasks, we are going to use one pooling mechanism Okay, so one pooling mechanism. So using that pooling mechanism, so all these models are to be generalized. So that means which is generated with minimum error. So for that, we are using this multitasking learning process in optimization, regularization. So in addition, training examples, so which we can consider like parameters to develop the model. So this model that is having generalized model, that is fine. But importance of this multitasking is we are doing pooling is important. For that, we are going to consider one shared task. Okay, so like we have a task 1, task 2, task 3. We are performing all these tasks with the support of shared pool. Okay, so shared pool is divides our task in multi levels. So this can be achieved in applying two types of multitask learning algorithms. So we are applying two types of multitasking algorithms. See this. With this diagram, you can easily understand how we are implementing multitask. So this multitasking, which can be implemented generic parameters with the support of generic parameters or with the support of task specific parameters. So using these two, we are implementing multitasking. Overall theme here it is like we are giving input. Okay, we are giving input as input vector or input matrix x1, x2, x3, and so on, xn. So we are giving input. For these inputs, suppose we are applying task specific parameter. So here it is considered this input label is performs only a particular task 1. So it generates output 1. Okay, so similarly, when we are using this input variable to generate one particular output, task 2, okay, so we are going to generate task 2 for the same input value. So same input, it performs one task. Same input, it performs another task. Means we are using a model. So one model for generating this output, another model for generating this output. Two models. Two different models we have applied. Here model is nothing but an algorithm. Two different algorithms will generate two different tasks. So individual task. So we can say this type of task, we can call it as a task specific parameters, which can be done in layer by layer. Here, H is a hidden layer. Okay, H is a hidden layer. As per the multitasking, here we are using a pooling. Okay, so this H shared layer, we can say it is a sharing object. So this object divides our model in different shareable components, shareable models, algorithms. In the next hidden layer, so actual model is implemented. In the intermediate layer, actual model is implemented, model 1, model 2, model 3, and so on. Then we generate output in the top layer, output layer. So this we are doing, and comes into the generic parameter layer. That means for these inputs, we are using one pooling function. That pooling function is aggregate all these models as a single unit. Okay, so this pooled intermediate pooled layer will be working like a low level layer. Okay, lower side we are mentioning. This is pool all our data. It pools all the data, all the models, and it predicts the output. So this type of multitasking mechanism is very useful for controlling the overfitting or underfitting problems. That means regularization will be done with the support of task, because we are taking average value of these models. So average value is always gives more and accurate comparing with any different type of model. Say for example, it generates output like 0.8. It generates output accuracy like 0.7. Say for example 0.4. So when we consider this model, accuracy level is very low, so we are not preferring this. When we consider this model, accuracy is high, so we can consider this model for generating the task, performing the task based on the learning experience. So when we are using multitasking mechanism, we are pulling these two and then we'll take the average value. That gives always for any model, we can consider pooling value, average aggregation value, that gives more accurate and more useful outcome prediction. So for that, we are using so many ensemble learning models. Those ensemble models we'll see in the next slides, upcoming slides. So this is multitasking, which we are implementing in our model. Then comes into the early stopping. What is early stopping and why, when we are going to stop learning the model, I mean, stop developing the model. So as you know that we are going to consider this capacity value to control the model. So why we are considering this capacity value? That is most probably which controls or which optimize from the overfitting and underfitting problems. That means complexity of the model is high or complexity of model is low. Then the predictions will be changed, outcome will be changed, so that we are applying this capacity value. So when we are applying stopping mechanism, early stopping mechanism in this model control. So see here, it means to obtain a model, a better validation, that is better validation error, by returning into the parameters setting at particular point of time. At particular point of time, remember, at particular point of time, with the lowest validation error, so we need to generate using early stopping. So when we are using early stopping method, so better validation error will be considered. Better validation error will be considered. How we are going to consider better validation error? By setting parameter at particular point of time. Say for example, we are designing a model. See this model. While designing a model, so this model is generating, we can say this is blue line. Okay, this is testing error. Testing error. This is generalization error. Okay, so when we are designing a model, the model is error is coming down, generalization error is coming down, as well as testing error is also coming down. So while predicting the model, while generating the model, at particular point of time, this generalization error is increasing again. Okay, the generalization error while constructing the model, it is reducing level by level, but particular time period. After that particular time period, the model generalization error again it is increasing. Error is increasing. So increased error is not at all suggestible to consider. That model gives misclassification. So we are not considering this increased error. Our target is as much as possible, we are reducing this error. So here we are considering capacity value. So at particular point of time, we need to stop. What is that particular point? When we have to stop our algorithm, I mean learning model. So that indicating early stopping. Huh? 1 second. One second. Now it is clear? Yes, sir. Okay, thank you. So starting onwards, there is no screen. ఎప్పటి నుంచి లేదమ్మా స్క్రీన్? ఓకే ఓకే So early stopping mechanism. So when we are going to stop learning model, that means when we are going to stop our model upgradation. So when we are doing upgradation, weight updation will be done. or the model will be updated as long as the predicted output is having more error. Error value is more, then we are going to update the model by applying some gradient descent algorithms. Delta value should be applied. That means weight updation should be done level by level. So while designing the model, when we are going to stop our model, how to find that stopping point while constructing the model with the updation of the weight value. So that is our main motto when we are going to identify this stopping point. So for understanding the stopping point, so we are considering capacity value. This capacity value is considered from the graph which we designed here, like a overfitting and underfitting graph. Okay, so you know that this point we can optimal capacity value. That means it is a best capacity, best fit model. At this particular point, we are identifying model is best fitted than this point, this point, this point, as well as all these points. Why means this generalization error is having high. So when the generalization error is high, then that model is overfitted. That means complexity of the model is high. Model complexity is high. When we have a, we can say error is high, here also generalization error is high, as well as this is test error, or sorry, train error. This training error is also high. Then this model comes under underfitting. The model capacity is low. What is capacity high? What is capacity low? Model capacity is low. That means when the model is complexity is high, indicating that it is having more number of features. It is having more number of features. It is having all the features which is defined in the model. When we are using underfitting, a model complexity is low. That means that it is having less number of features. Less number of features which gives wrong prediction. More number of features also which gives wrong prediction. So we are finding optimal. This concept is repeating everywhere. Entire deep learning, this point comes several times. As long as when you are able to understand this capacity value, then it is easy to understand all deep learning, machine learning algorithms, because all are depends on the optimization of the model. Okay, for this optimization, we need to stop our model, designing of a model at particular point of time. This is particular point. How we are identified this is exact point, optimal point. ఇక్కడనే చెప్పొచ్చు కదా ఆప్టిమల్ పాయింట్, ఇక్కడ ఉంటుందని చెప్పొచ్చు కదా, లేదంటే ఇక్కడ ఉంటుందని చెప్పొచ్చు కదా, లేదు అంటే ఇక్కడ ఉంటుందని చెప్పొచ్చు కదా. అలా కాకుండా దీన్నే పర్టికులర్ గా ఐడెంటిఫై చేస్తున్నాం. దిస్ ఈస్ ఆప్టిమల్ పాయింట్. హౌ we are identifying this point as a optimal capacity point? That we are going to identify using early stopping mechanism. One of the mechanism is early stopping mechanism. So till now, yesterday and today's beginning of the class, we learned how to reduce this error. So how to reduce this error? For reducing these errors, we are using normalization, norm penalties, penalty constraint, penalty under constraint mechanisms, multitasking mechanism. All these mechanisms are used to reduce this error. That means we are reducing this error gap. That means green line should be near to blue line. So that we are going to consider. 3 topics or 4 topics which we have learned in the last class. Now today we are learning when we are going to stop this point. Model has to be stopped. This stopping point is defined like this. The better validation error, the model has to be stopped when it reaches better validation error. Better validation error. How we are achieving this better validation error? By setting some parameters. At particular point of time, we can achieve best model. Okay, what is best validation error? Generalization error is also called validation error, that is test error. So when we have a best test error, so see here in this diagram, it is having highest test error. This is also having some sort of highest test error. What is the best value of this test error, generalization error? Say, for example, this is 40, 40, 30, 20, 10. So say, for example, this is 5, this is 0. So at particular point 5, okay, at particular point 5 at y-axis, at particular point 1 or 5, say for example, we'll take scale 1, 2, 3. So x-axis 3, y-axis 5. In this particular point of time, the model will be having best error, that means minimum error. So this minimum error is going to be considered where we are going to stop our model construction. So if we are not stopping here, what happens? The error value increase. If the error value is increased, then obviously that comes under overfitting zone. If this error value is increased, it comes under underfitting zone. That means either overfitting or underfitting will be happen if we are not stopping in this particular point of time. So this point we can say we need to stop evaluating the model. That is the final prediction or final output of the designed model, designed algorithm that we need to consider. Okay, so for that we are using this early stopping mechanism. See this algorithm. Nothing is there. You don't. It is having like a full screen, but it is not having anything. So first we can define theta value is equal to theta naught. Because it is a parameter, we need to reduce parameter value. In the last class, I explained why we are considering this theta value and weight parameter. The weight parameter updation is depends on the theta initial parameter. And initial, I'm going to define iterative variable because our algorithm has to be repeatedly perform the operation until reaching a minimum generalization error. So this is I is an initialization variable, like we are using in for loop or looping variable. J is also one of the looping variables. Say for example, we are using 2 loops, so we are going to define 2 variables, like how we define in programming, like int I, int j, looping variables. And I defined one parameter, integer parameter, theta naught. Okay, so that means theta equal to theta naught. I am assigning this theta value to theta naught. And the value, this is v indicating is a value. So initial value we can consider infinite. Infinite times we are going to repeat our task because we don't know where we have to stop. That we need to identify. And theta star equal to theta. What is theta star? Updated weight value. Updated weight value equal to theta. So what indicating this? This is nothing but initial value we assigned first. Then when we are updating the value, initial value will be changed to the next level, next level, next level. Like that we are updating parameter value theta. So star indicating obviously it is an updated value. So this is a parameter, updated parameter we'll consider. Star I is updated iterative value. Okay, updated iterative value means I equal to 0 initially. So now I'm updating I value equal to 1 next time. So this is indicating like that. So while using this loop statement, we are going to initialize a parameter updation. The training algorithm will stop at n steps. This is going to be run n times. Theta value is updated every time. And I value is increased, I equal to I plus n. V dash equal to validation error. So validation error, that means after creating the value, error value is calculated like actual value minus actual value is y minus predicted value y dash. So what is this? This is error. So initially we'll calculate error. This error value stored inside V1. V1 is less than V. That means what is V? Infinity. So V1 is less than infinity. In this model, you just see this is infinite. This is infinite. This is V1. Somewhere it is V1. So this V1 is less than infinity. Then we are repeating this one, assigning the weight value, updating the weight value, updating the I value, updating weight value. These updations will be done when, as long as the condition is true. So whenever this weight value is changed, this algorithm has to be stopped whenever it is not satisfying the condition. The algorithm terminates when no parameters have to be improved over the best recorded validation error. So when we are stopping this, we are going to identify this value, best value, V dash is less than V1, as long as V dash is less than V1. So that means every time V dash is assigned to V, that means infinity V dash, initially we are comparing with this, V dash is 1, V dash is 1, this value. Next time V dash is 2, compare with V1. Sorry, V1 compare with V dash. Like this we are comparing and identifying when to stop. So that updated parameter value will be considered as a parameter that we need to set at that particular point of time to stop the model. That gives better error, minimum error. So this is the thing we are applying to stop the model. So that particular point will identify better estimation. So like that, we are using one of the simplest mechanism, model optimality identification, model capacity, using we can say it is a early stopping method. Sometimes we are using k-folder learning algorithms, ensemble learning algorithms. Those algorithms will come under optimization topic, last topic of the unit. There I will explain how to do other algorithm optimizations. Sometimes we can apply sparse representation. This is also gives minimum error. Optimization of the algorithm, regularization simply. So how we are performing this sparse representation? The weight decay. What is weight decay? Weight decay is nothing but reducing the weight value. Reducing the weight value act by placing a penalty directly on the model parameters. This is, we know very well, that is norm penalty. We can apply penalties to reduce the weight value. Another strategy is we place a penalty, activation of the units in a neural network, encouraging their activations to the spots. Using spots value, we can reduce the weight value, weight error. Error value should be reduced using spots representation. So this is indirectly imposes complicated penalty on the model parameters. That means this is also one type of applying a penalty, but this penalty is very complicated one than the normal. So normal one directly we are updating weight value in terms of norm, gradient value, but here we are applying a spots. So what do you meant by spots here? So this is derived from the matrix, spots matrix. So this matrix, we are going to take our input values, a vector value, and we are updating the weight values, and weight values will be considered as a matrix. So input value. So input is a vector, input vector. Okay, say for example, x1, x2, x3, and so on, xn input vectors are multiplied with matrix. Okay, multiplied with matrix. This is weight matrix. Weight 1, 1, weight 1, 2, weight 1, 3, weight 2, 1, weight 2, 2, and so on, weight mn. So these input values are multiplied with weight values. In this process, we are going to consider these matrix values or these matrix values as a spots. So sometimes vector is also called a matrix, similar row-wise vector or column-wise vector. We can say row-wise matrix, column-wise vector. So we can consider these matrices as a spots matrix. So what is the meaning of this spots matrix means? A matrix which is having maximum zeros than non-zero elements, maximum zeros than the non-zero elements, then we can say that matrix is a sparse matrix. So such kind of representation will be considered to apply our generalization mechanism penalty in terms of sparse. See this example. So we are considering here, this is one way of representing sparse. This is one way, one method. So using this method, what we are doing, we are considering input value and our target is we are predicting the output. So for that, we are considering the input value. And this A matrix is nothing but it's a real matrix, M by N real matrix. This A value or considered matrix is considered having weight values. So weight value 1, 2, 3 and so on like this. So we are multiplying these input values with weight values. This matrix is having more zeros than non-zero elements. So see for example, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. That means 5 by 6 matrix. 5 by 6 means it is having 30 elements. Out of these 30 elements, how many zeros, how many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 elements are non-zero elements, remaining 20 elements are zero elements. So maximum elements are zero elements, then we can say it is a sparse one. So using this mechanism, we are predicting the output. So this output will be having some sort of regularization will be applied. This is one way. So another way of representing this sparse one is, so you can consider the input values is having more zeros than the non-zero elements. It is having only 1, 2 non-zero elements, remaining 1, 2, 3, 4. 4 are the zero elements. We are multiplying these with the normal, which is having normal values like a vector B is a weight vector. It is having more non-zero elements. Either input value or a weight value should have maximum zeros. Then we can say it is a implementing sparse mechanism. That representation we can call it as a sparse representation. Through that we are predicting the output. So our output value, predicted value y, is equals to mx plus c. C is a constant and x is the input value and m is a slope variable. Similar to that, we are applying this along with some parameter k. So this is the mechanism we are applying the sparse representation. Simply we can say this is one of the regularization technique. Another important regularization technique is bagging. So bagging is one of the important regularization technique. This comes under ensemble method. Bagging and boosting also there. Bagging and boosting technique. What is the meaning of this bagging? Bagging, we can also call it as a bootstrap aggregation. Bootstrap aggregation. B-A-G-I-N-G, aggregation. Bootstrap aggregation. From this we consider boot bagging. Like this we define the name bagging. What is the mechanism we are implementing inside this bagging? Here, so we are going to consider a dataset values, and we are generating the output value y. So this output is generated by using bagging mechanism. That means the model is constructed in different levels by using different models. This is model 1, this is model 2, this is model 3, this is model 4 and so on. After constructing the models, each model gives the output. Each model, it generates the output. So we are going to identify a best one by using averaging of the models, aggregation, average. So by using that average value, we'll predict the model output. Instead of considering single model or 2 models or 3 models, so we are going to do aggregation of the models. That model output will be predicted as a output. This is the mechanism which we are doing in ensemble model. Ensemble means combining. Okay, this is bagging is one of the ensemble mechanism. So using this bagging mechanism, we are combining, we are connecting several models as a single model output by using aggregation. Okay, dividing this data set into different models, we are calling it is a bootstrapping and aggregation. By connecting bootstrapping and aggregation, we are generating the output. So we can say it is a bagging. In general, we can consider like an example. A particular patient is having a disease. Patient is having a disease. So this patient, how he is going to take the medicine? How this a person is going to take a medicine? Usually what we are doing, we are consulting a doctor. So based on the doctor's suggestion, a particular patient will take the medicine. Sometimes due to this medicine, his disease is not cured. What we are doing, obviously we are going to consult other doctor. So this doctor gives different prescription. This patient follows this prescription also. Even though it is not reduced, he is consulting another doctor. Like that, based on the disease, particular patient is consulting several doctors. So in this situation, he has to apply different medicines, which is having a different prescriptions defined by the doctor. So this gives more impact, other side effects to the patient because he is using different types of medicines by prescribed by the doctors. Instead of doing that, the patient has to consult different doctors and make his own decision. Who is a good doctor? Who is giving best prescription to reduce the patient disease? He is going to take that particular decision, average decision, or he is going to select voting mechanism. I'm going to prefer doctor to prescription is having very less effects and side effects. So I'm going to prefer this doctor medicine. So I'm going to implement this medicine to my disease. Like that, he is taking a decision. So same kind of thing we are applying in bagging. So we are going to design several models. After designing the models, so we need to identify the best model by voting of these particular outputs. That is aggregations and connecting, combining all will take one decision. This is called a bagging mechanism. This is one of the ensemble model, particularly used for regularization. This is about the bagging. This is example. Another example you can consider. See, original data set is having like numbers. With this, I am stopping today. I am completing this boosting, bagging boosting, and so on. So we have a data elements, original data elements like 9, 6, 3. What we are doing is, first we are resampled this data set like 8, 6, 8. That means we are going to take a different samples and we are applying some model. So using that model, we are predicting output like this is 8. Okay. With this model, we are generating the output, predicted output like this. So based on this predicted output, we can map this 8. It is having some error. What is the error? Remaining part is not visible. That is error. The second model is used like 9, 9, 8. This input. It generates like this is the output. For this output, we can say we are stopping the model construction and assuming that this is 8. Okay. So with this model, whatever we are assuming, this is maybe a 8 or maybe a 9. 9 is also having similar end. 8 is also having similar end. Correct? So maybe it is 8 or 9. We don't know, but we are assuming this is 8. This model predict like this. So using this model, we are predicting some output bottom side. So this is bottom side having a circle, bottom side having lines. Here it is circle. So we are predicting like this. So in this example also, top side is having 8, like a circle. It is having line. So we are predicting. This prediction is accurate only for these data values. Only for these data values. When we are giving new input, when we are giving new input like 9, for this also it has to predict 9. But as per this definition, it may predict 8. Based on this, it may predict 9. Some error will be there. How we are reducing this error means by combining these two as a one unit. By combining these two as a one unit. That means output 8 is predicted based on this model, and by connecting this model, then it gives accurate output. Even when we are giving input 9, it is not having a second model related output. So this is not 9. This is not a 9. So it is identified as a 8. Try to understand these things. In online class, it is difficult to understand. Try to understand this. So by combining these two will make our decision. So this connection combining, we can say it is an ensembling. We are ensembling these two models. By ensembling these two models, we'll predict the actual output as a output Y. So this is having less error compared with the individual models. This is having less error. This is the main internal concept behind this bagging. So ensemble method. So similarly, we are using boosting. Bagging is weak learning model. So we can say it is a weak learning model, even though it is having some benefits compared with the earlier models. But we can say it is a weak learner model compared with the boosting. Boosting is more powerful than the bagging model. How we are doing boosting here? The boosting is done sequentially. What is the meaning of sequential? Earlier, bagging is done parallelly. So see, this is model creates parallelly. This model creates parallelly. And we are combining these two. Parallel connection or parallel model development. But here we are using sequencing. First, we will predict output. If this output is having error, so based on this output, we'll modify the model and we'll predict the output. Based on the error, we'll modify the model. We'll predict the output. Like this, repeatedly we are doing updating weight value based on the error. We are modifying the model and creating new model. This model reduces the error. So, and error value will be identified, and we are applying another model. This model reduces the error. Like that, we are getting optimal error, minimum error, up to reaching that maximum optimal error. We are repeating this sequential model development. After error, comparing, again model developed, error identified, based on the error, model developed. Like sequentially, we are doing this thing. So we can say it is a boosting model. So it boosts the weight value reduction. Error value will be boosted. That means reducing the maximum level so that we'll achieve more accuracy. So this is one of the technique we are using. The dropout and other things we'll see in the next class. Okay. Now we'll summarize what are the topics we covered today. Today we learned multitasking. What is a multitasking here? Multitasking is done by dividing our model using some shuffling point, intermediate level, shared point. This shared point works like a pool. It pools a particular model design using layers, hidden layers. So in this multitasking, we are applied to two types of things. One is task specific, another one is generalized. This is first one we learn. The second one is the important thing. So this is the sparse one. Using sparse representation, we have reduced the error. This is using like a maximum 0 values, either input side or the weight vector updation that will be implemented. So another technique is ensemble model. Ensemble model where we implemented bagging and boosting techniques. Using these, we are regularizing the model. These are the topics we learned today. The tomorrow, probably, if possible, I will take class tomorrow. Otherwise, I will take on Saturday. Saturday, I will see. Saturday, I have some other work. I will give you well in advance 1 day before when I'm taking class. In that next class, I'm going to finish a particular third unit. I'm going to finish. So third unit, I'm going to finish in the next class. Maybe next class I will take Friday evening, Saturday. I don't know. I will check it out. I have some work in this week. So I will take maybe Sunday, Monday, next Monday. I will tell you. Okay. This is information from my side. If you have queries, raise your queries.